promise not to spend the whole lecture on this, such that tomorrow I finish it and you guys have more time to work on it, right? Okay, so pictorial views. You have a couple of pictorial views. You have the perspective. You have single point perspective, 2-point perspective, 3-point perspective. You have different type of oblique views, and you have your engineering isometric view, right? Back in the day, let's talk about the first one, which is perspective view. It's how people would perceive things, just like you would see it in a photograph. The one that you guys see here, it is what we call it a 2-point perspective. You have two vanishing points and a horizontal line or horizon line that joins those points together. Back in the day, there was no concept of depth until a guy, which you see, his name is Filippo Brunelleschi, on the 15th century. This guy, he came up with a way to get this point perspective as you would see it on a regular picture. So let me show you what I mean. Okay, let me see if I can show you. All right, so how do you make a single point perspective? And you guys pay attention, right? Just in case I ask you during an exam, and I tell you, make me a single point perspective of this, and you're like, what the fuck? What is that? Okay, let's do single and 2-point perspective really quick. Let's see. If you were to do a 2-point perspective, you start with 2 points. Let's do 2 points. One right there and another one right there. Okay? And then you create a horizon line, which means put a line right in the middle, right? And then you start making a bunch of lines that are to an angle. See if I can do it. You do the same thing on the opposite side. And then you do the same thing from the other side, right? So we come over here. And you do the same on the other side. Okay, let's go back to the beginning. Again, all I did is I created 2 points, I created a horizon line, and I started making a bunch of lines from my vanishing point. You see it? All right. Next, let's say that I want to make a street. My street is going to be somewhere here, right there. Let's put another one somewhere here. Let's say this is going to be the corner of the building. And the way you do it is make sure that you only follow the vanishing lines to the vanishing point, right? And you do verticals and the ones that go to the angle, right? So let's say that I want to do a building and that guy will go over there. So a bunch of verticals. Let's go up. Let's go down. Go there. Go there. Go there. Let's put that one there. Let's put that one there. That one goes up, down, this. Like that. Up. And again, follow the horizon lines. Let's say that guy goes there. Let's put a street. Say that one will go there. Let's put that one there. Let's say this one is going to be the corner of the street, right? Let's do a stop sign. Let's get a couple of lines in the middle. Somewhere there, right? Let's get some windows, right? And again, you guys can go crazy on the detail, right? Put 20 windows and start going with the shading. Come over there and come up with trees, right? And then you name it, put another one somewhere there, right? And go crazy at it, right? What you guys would notice though, you guys would notice when in my 2-point perspective, that it all started with 2 points, right? The 2 points put together, you have a horizontal, a horizon line, 2 vanishing points, a line that creates. That's 2-point perspective. One up. I mean, I don't expect you to do a 2-point perspective, but you should know what it is. Yes? Okay. Let's go back and let's talk about the next one. Actually, we already talked about it. The other one is the single point perspective. Let's do a single point perspective. So if that is a 2-point perspective, what would a single point perspective be? 1 point, right? I'm going to put 1 point, and then that point is going to have all the lines meeting to that point. So let's go crazy at it. All right, that kind of looks like a point, right? Let's say that now I want to make my street. Let's say that's going to be my street, somewhere about there, right? And then I'm going to go here. And then in here is going to be my sidewalk. Let's say that's going to be the center of the street. Let's do the other sidewalk. You guys can go crazy on the detail too, right? Let's say that here I have my building. And then that one will go there. You guys can imagine how this guy can go, right? And then you'll do the same concept on the opposite side, right? So here upwards. Let's say that one goes here, go upwards, go sideways, come over here, right? You guys could start putting some windows, something like that, boom, 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 boom. A couple of, you name it, right? I mean, I'm not gonna do the whole thing. I just want you guys to understand single point perspective, 2-point perspectives, right? Okay, question. Are these engineering drawings? No. Oh. So if you're this is not an engineering drawing, then most likely I won't make you do it. But you should be aware of what they are. Okay. Let's talk about the next type of views. And again, all of these are pictorial views. The next one is the oblique drawings. Oblique drawings is one of those drawings that is the easiest ones to draw. Usually, what you do is you grab the front view and you draw it exactly in the front, and you grab the front and you put it on the back, like this one. Okay. What are the advantages of the oblique drawings? Well, the advantages of the oblique drawings they are really easy to draw. Like literally, you can draw them. That thing took me maybe I don't know 2 minutes. That guy would take me 10 seconds. It's really easy to do. Okay. And you are really good when you go and you have prismatic constant cross-sectional shapes. Something that has it starts at the beginning and then it continues to go to depth. Like my ruler. See it? Constant cross-section. Just continue in the same section. What are the disadvantages? Okay. What you guys see here is meant to represent a cube. If I were to grab, remember you have width, height, and depth of the cube. The 3 sizes should be the same, right? Width, height, and depth should be all the same. So if I were to draw a cube here, where I have my width, my height, and my depth all at the same scale, does this look like a cube? Does it look like a cube? No. Okay. Let's say that I'm going to do it about half the way. Instead of saying width, height, and in terms of the depth, I'm going to grab half of it. I'm going to put it there. Does it look like a cube? It's kind of like it's your judgment, right? You can also do 3/4. Say, okay, now I'm going to do the half. I'm going to do a little bit more. I'm going to put it right there. Now, you guys probably will say, you know what? I think it's somewhere between the middle one, half scale, and maybe the 3/4 scale. Maybe I don't know which one looks more like a cube. Judgment, right? Judgment. Question. Is this an engineering drawing? What do you guys think? No, it's not an engineering drawing. But you guys still need to know how to make it. Okay, let me show you how to create ones. Back in the day when I was a student, I was a youngster, like 12, 13 years old. I used to love to draw. In fact, before I became an engineer, I wanted to be an artist. I was like, man, I want to make me. I was able to do everything. I was able to paint, sculpt, you name it, right? And then eventually life hit me, you know, and I did my whatever, right? But I used to like to put names, you know, like Rasta names, like Gangsta, you know. I wasn't a gangsta, but I thought I was cool when I was little, you know. So let me explain you how you make this. You guys probably have seen this. If you go to downtown, right? You see a bunch of people with graffiti, they put people things, right? All right, this is how I used to make it. And I wasn't in Mexico doing this, okay? I promise. I was just do it on paper. Let's start with putting my name, right? So the way you do it, you start with the true size. So I'm just gonna put my name. And I'm just gonna do. I'm just gonna put a couple of letters. I'm gonna do. This is my escalona, right? Okay, first you make your letter. Okay. Second, you choose the direction or where you want your lines to be. You can make them that way. You can make them that way, or you can make them this way, right? Kind of like give it some type of depth. Let's say that I want to go that way, right? And you can choose any direction, right? So you go, and every time that you see a corner feature, that's where you make your line. So I'm gonna go boom, 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 boom. Easy peasy lemon squeezer, right? Then whatever I see on the front, I put on the back. So let's say this guy will be continue there. Put that guy in the front, and then that one there, and then boom. And then right after this, you go crazy on the shading, right? Usually you will go and say, no, I'm gonna make that guy to try to give it like the effect of the depth. Make this guy a little bit darker, right? And then right after that, you start giving an effect on color, and then you start making sparks. And I mean, you play with the color, right? But as you guys will notice, easy peasy lemon squeezy. All you have to do is make a shape, make a bunch of lines on the side, and then whatever you saw in the front, try to copy it on the back. This is a type of oblique view. I didn't know what it was called back in the day, but easy peasy lemon squeezy to do. You guys will learn different type of oblique view. I believe maybe tomorrow when we meet, I will do an example so you guys have a better idea. Okay. Okay. Next one. Okay. So we just talk about perspective drawings. Again, the pictorial views, we have perspective drawings, we have oblique drawings, and we have isometric views. Within the perspective drawings, we got 1 point and 2 point perspectives, and there are other type of perspectives that you can also have. And the oblique views. Oblique views, the front and the back go the same. Now, engineering drawings. What you guys see here is an engineering drawing. It is composed of a bunch of things. Right? And again, it really depends on what kind of branch you're doing, right? Because if you get to do civil drawings, that will be completely different than this one. Right? What you guys see here, this is a mechanical drawing. And I usually like to teach mechanical because it's easy, right? You can teach really quick, really easy. If you want to do a civil drawing, it will take us months to complete, right? That's why we don't teach. We teach about another course. This one is just mechanical, easy, easy, easy. Okay. You guys will notice this drawing has a couple of things. Well, first ones, you guys will notice that it has a front view. You guys don't see what the front view is. You have your isometric view that is looking at the part that way. You create your front view. You create your top view. You create your side view, right? You guys will notice that it has a bunch of center marks, a bunch of hidden lines, a bunch of center lines, and then it has the regular dimensions. And when we get to that point, I'm gonna teach you how to do it right. You don't put dimensions wherever you want. There is a standard. Okay, we're gonna learn how to do it right. And then you guys eventually will see a bunch of symbols, bunch of numbers, and they're calling out in a certain location. Right? There's a language out there. Mechanical people have a book of languages. It tells you all of these symbols. You guys will learn a couple of symbols in this class, okay? And what they mean. If you have a part, most likely you will notice that actually all the mechanical parts, I don't know if I have mechanical parts here. If you guys look at the one that looks like a ring, that's mechanical. The one below is mechanical. All of the ones that you guys see in the middle, those are civil. You have a mechanical part all the way to the back. You want to see the other ones? They're also mechanical, right? And by standard, back in the day, they used to do these isometric views as optional. Why? Because they did it by hand. In fact, when I learned it, I learned it by hand. There was no CAD. Actually, CAD was coming up. Right? Now it's as easy as a click of a button. Not too long from this, we're going to start using software. I think after this, we're going to start using software. And then you guys will notice the difference between click than making it by hand, right? How much harder. So you guys will learn how to do it by hand, and then you guys will use the software to be able to create three-dimensional things. Okay. All right. You also have a bunch of notes. You guys will notice that the notes, it tells you your standard. Interpret drawings per ASME, American Society of Mechanical Engineers, based on the Y14.5 2009, which is the current standard back in the day. Now, the current standard now is 2018. Okay. Then I will tell you what type of, you have inches or millimeters. It gives you your linear tolerances, your angular tolerances, and then it gives you a check mark, which talks about surface finishes. We will talk about it later in the class, okay, what all of this means. It also talks about fillets. It tells you your material. It tells you your quantity. Sometimes when it goes actually into manufacturing, you will have a revision table. And that revision table will tell you how many iterations it went before it became a final product, right? Okay. But the topic of today is how to make an isometric view. Thumbs up. This is an engineering drawing, by the way. And this is an engineering view, an isometric view. So I expect you guys to learn how to do them. And to make sure that you know how to do them, you guys will have an assignment. Okay? Let's say, how do you make one? Okay. Let's see, how do you make it? See, let's start with this one. Step number one. Step number one. You guys are going to grab your orthographic views. I know you guys already know how they are, right? Orthographic views? Yes. So I think you guys are going to go vice versa. Instead of giving you guys the isometric view, I'm going to give you the orthographic views. And then you got to go from the orthographic views to the isometric view. Okay? So you have a top, a front, and a side view. And from your front, top, and side view, you can do the sizes. Usually what I like to do is I like to make a little cube here on the side when I have my top, my front, and my side view, right? So you know that in the front view, you have a width and you have a height. Yes? Front view, width, and height. And again, by the way, the height you can also see it on the side, right? You can see here, right? You also have a depth. The depth, you will see it on the side view here, or you can also see it on the top view. Right there, or right there. That's it. Step number one, go and look at your view that you have to make and find out the width, the depth, and the height. Okay? And write it down. Step number two, you'll get yourself a triangle. Shoot, man, this is, I told you guys to go by hand, right? So we're not going to do triangles. You don't have to get your, did I ask you guys to get triangles for this class? No. Okay, you don't need it. You go get yourself your engineering paper and you start by making a Y. I don't know if you can see there is a Y right there. Right? Yes. And that Y is 120 degrees with each other, right? 120, 120, 120. Yes. So if I were to make a line that's straight, that would be 90. Yes. Now what about? Come on. 30, right? Okay, so when I go and I draw it, I need to make a 30 degree line for horizontal. Yes. Okay, so the cheat way is you have engineering paper, yes? And if you guys want to know, remember about the engineering paper, it has a box that is bigger. You count 2, 4, 5, 1, 2, 3. Connect that one to that one. This guy is about 30 degrees. How do you find a 30 degrees on a line that you know horizontal to vertical? So Katua, right? Tangent inverse. OA, opposite over adjacent. And you will get about 31 degrees. How many degrees are we supposed to do? 30, so pretty darn close, right? So when you guys do your Y, you choose a point, and we're going to talk about the math of how to center it, right? But you choose a point, make a horizontal, do 5 to 3. Boom, done. Connect those two lines, you get a Y. Yes? Okay. Next. If you guys recall, we got in the width, the depth, and the height from my orthographic views. That's why we have front, top, and side. But I was able to get those dimensions. Yes? I got my Y, which is right here. I move by H, I move by the depth, and I move by the width. And then I get my box. Thumbs up? Yes? And then you start sculpting up. You start taking little chunks, right? And again, we will do examples tomorrow, most likely. You start chopping a bunch of things, and then eventually it looks like this. Yes? Easy peasy lemon squeezy? It goes from there to there to there. Get rid of the construction lines, and you will end up right there. So, I'm not going to do it today, we'll do it most likely tomorrow. Tomorrow, I will come up with crazy part that I have over there, and we'll do an isometric view. Then we'll also do a couple of oblique views. So there are different types of oblique views, by the way. And then we'll talk about your assignment, which will be due next week. So that will give you a whole week. Okay. Actually, no, I moved there, right? This is a whole week. That's a lot. Well, okay, you should be busy. You should have what you got anyway. You're going number 2, right? And you should be able to create orthographic views. Your homework. You actually look at it really quick. Homework number 3. Homework number 3. Let's take a look at your homework number 3. For each of the 3 parts below, make a freehand sketch. This is a ruler sketch. No, I will be penalizing like crazy if you make it with ruler. I'm letting you know. Use a ruler. If I see you guys using a ruler, I won't even grade it. Okay? Advanced sketch. Make a freehand sketch on engineering computation paper. Show the three orthographic views and a 45-degree cavalier view. Which we will do in lecture tomorrow. And an isometric view, which we will do tomorrow. For mine, just like the step log sketch on the bottom of the sketch. Can I give an example? Oh, look at this. I think I did. And that's how we're really bad penmanship. Right. But this is the way we want it to be oriented, okay? We have front, the top, and the side view. It's oblique, don't worry about it, we'll do it tomorrow. It's going to start, right? Okay, you guys are caught up? You guys can start on this one, okay? Right, it should be busy. Let me move this guy out of the way. All right, so if you guys recall correctly, last time we met, we introduced you guys to perspective views, oblique views, and isometric views. The perspective views, it is as you see it, as it's visible by the person's eyes. There are two types, actually, there are more types of perspective views. I just showing two of them. You have the single point perspective and the 2-point perspective. And again, this Filippo Brunelleschi is the one that came up with this because back in the day, they didn't have an idea of what was, they didn't know how to do it correctly per se. And again, Filippo Brunelleschi is the one that came up with the perspective views. And the example that you guys see here, it is a 1-point perspective. And I'm going to assume that you guys could see that everything gets to be somewhere in the middle. And then you get a bunch of lines here that kind of like move away. And then they do a bunch of detailing that shows. Once you give it detailing in shadows, it usually start becoming a little more realistic. But I'm going to hope that you guys could see that everything comes from the center. There is a point, vanishing point somewhere here. And we did a couple of examples in our lecture. We also have the oblique drawings. The oblique drawings are the ones that are the easiest to draw. And pretty much what you do is you get your front view, typically, get your front view, or the shape that is the most complex. You put it in the front and then you copy it to the back. Not completely done the whole thing. I believe I show you guys my Escalona name, which pretty much uses the oblique drawings. It is easy, especially if you guys have parts that have a constant cross section, because the section will not change, so you have to do the front to put it on the back. And again, we also talk about the disadvantage. You have the general drawing, the general oblique drawings, which are between a half and a full, right? You have, this is a cube, right? This is my width. So if I were to come over there and I were to chop it in half, right? So I say somewhere in between here, let's say about 3/4, let's say from here to there, this distance, that's what this distance will be, right? So whatever width, I give it 3/4 the way, between a half to a full, so let's call it 3/4. You also have the cabinet. The cabinet, you grab half of it and put it here. And the regular cavalier, you grab full size of the depth for the width, and you put it for the depth. That's the difference between them. All of them are oblique drawings. They just have different names. One is called the cavalier oblique drawings. The other one, they call it the cabinet, and the other one, they call it the general oblique drawings. Okay, let's focus first on the isometric views. And if you guys remember, the first thing that you do, you make a Y, then use the cheat way that I told you. You put 5 to 3 squares. That will give you a degree of about 30 degrees. You make your box. After you make your box, you start sculpting the shape based on the front, top, and side views. And then eventually you get rid of everything else, and your part will go from a Y to a Q to a bunch of lines all over the place until you are pretty much done. My best to show you how to do this. I usually go and I do it on my computer. I can actually scratch on the computer and draw it. But it's really hard because I notice that a lot of people, when they go and they actually do it, they don't do it right. And I'm going to assume the reason why they don't do it right is because I don't show you on a piece of paper. Now, unluckily, I don't have engineering paper, so I'm going to do my best to show you without engineering paper. So you can see that it could be done. Let's see, grab this. You can see that it could be done. There we go. You guys can see that it could be done without engineering paper, right? It's called sketching, right? So sketching, you should be able to do it. Okay. This is what I'm going to give you, which is pretty much your orthographic views. Okay, let me grab this, make it a little bit smaller. And again, I'm going to maximize myself as once I have kind of like an overall shape. So you guys will most likely will come up with your ortho views, and again, this is gonna be some rough sketch that I'm gonna do, so I can have the views. Let's say I'm gonna be somewhere about there, the depth, so boom. How do I do this? 45 will be about there. Let's go here. Okay, let's say that one goes about there, 45 about there. Kind of like want to get the same depth. The same depth. Okay, don't worry about what I'm doing. I wish I had this guy printed out before, but I totally forgot. So sorry. Let me get really quick so we can start with isometric views. Let's say it's about there, and let's go another one about here. It's over there. It's over here. And again, we'll put here in lines too. And I'm not gonna worry about the line right now. It's again, I'm not supposed to be doing this one. Again, it's just I just forgot to print something so I could do it. I usually do it by the computer, but then again, I noticed that a lot of students they're not that great at doing it for reals. So I decided, you know what? Maybe the problem is I am not doing it. I'm not doing it by hand, and that is the reason why people get confused. Let me see. Let's do one more here. One more there. Okay, so those are the views. I'm going to assume that you'll be able to do these ones, and at this point in time, you say, you know what? I think this is what I told you guys can do. I say, go come up with your views, and once you have your views, orthographic views, then you should be able to come up with your isometric view. Okay, step number one, when you do your isometric view, you know that it's going to be a cube, right? So let's see if I can have a cube. And you don't draw this, okay? This is just for me to explain you. Okay, so you have your top view, your front view, and your side view. Your side view, your front view, your top view. Okay? Step number one is to come up with the width, the height, and again you see it on the side view, right? And the depth, right? You will see it here, right? In here, right? Okay, so let's probably grab this guy, and again you guys are gonna do it in terms of squares. Let's call this guy the width. And again, you guys don't put these dimensions in your drawing, they're just for me to explain you. Let's call this guy the depth. Let's call this guy the height. Okay. And again, here I also have the depth. And again, how do I see this? Well, this guy here is this the depth, right? And again, you can see it on the top view, or you can see it on the side view, like you guys see it there. You also have the width, right, which is this width. And then you also got the height. And again, the height, you can also see it from the side view, right? All right. After you have determined your sizes, which in you guys' case, you guys want to do it by squares, then you are ready to start kind of like figuring out where you're going to put it. So in my case, I don't have squares, so I'm going to have to improvise. So if this guy is going to be, if this is going to be at 30 degrees, then this is going to be my width. That means that my box will be something like this. I went about 30 degrees, will be about right there, right? And then my depth will be somewhere about there. I don't know if you guys can see it, about somewhere there, right? And I have a height that is about here, which means my height will be somewhere about there. So if I were to start the bottom of my box somewhere here, I should have enough space to put it in the drawing. And again, we're also going to cover it mathematically. In case you guys want to do this mathematically, you can. For now, I'm just going to start. So I'm going to start with a horizontal line. You guys will have your squares, which are going to help you guide yourself. In case I'm just kind of making a question. And I keep in mind that I'm doing like super light. Then you guys will have a bunch of squares that are going to give you 30 degrees. How do I know that I have a 30 degrees? Well, I know that this guy is 90 degrees, right? And if I were to grab the 90 and split it into three parts, so about that will be 30, 60, 90, right? You see how I'm doing it? Okay. So 30 degrees is about there, and 30 degrees is about here. Now, you guys have your blocks, which are green, that tells you that you can move sideways. You can get a green ones. You can move sideways, right? So when you're making your 30 degrees, all you have to do, you have a bunch of squares, and you go 5 to 3. 1, 2, 3, 4, 5 to 3. Grab the 3, you got the 5, connect them, and that will be your 30 degrees. Okay? That's how you will do this line, okay? Want to do it because I don't have squares. After you do that, then you can start worrying about the width. So you come over here to the width, right? You can also count the squares. And then you come over there and you say, okay, so that is about somewhere about there. That's about the width. You come over really quick, double check. It's pretty good. And then I come over here. I gotta get the depth. So my depth is about there. Come over here. So my depth is about there. And again, I can double check again. From here to there. It's pretty good. And then in terms of the height, I want to say the height is about J, right? And I come over here. And I'm pretty close to what the height is. Boom. Step number one, you make a Y, which doesn't look like a Y, right? But if I want to put a line below, it will look like a Y. I'm going to grab that side. And again, all you have to do is kind of grab your pencil and move it sideways. And that will give you the same angle, right? Grab it from the bottom, move it sideways, and it will give you from the middle. You can grab this one and move it sideways, and it will give you your straight lines. Sideways, move it straight lines. So in my case, you guys are going to have squares that are going to help you. I don't have squares. I'm going to kind of like just, and again, if you do it with your construction lines, it won't be too crazy. So let's say that guy's about there. I'll come over here, so that guy will be about there. And then you put this other one about there. And you guys got squares that are going to help you. Mine, I don't have squares. That's okay. You guys will notice that I went width, and you guys could see that's the width. This is the depth, right? I went width, and I put it there. I got depth from here, and then I put it here. And then I got height, and I put it here. Boom, I got a box. After you have the box, then you start sculpting. Let's say that I want to do, again, your coordinate system on your box is going to be, I don't know. Let's say these are going to be my main orthogonal views. Okay, X, Y, and Z. Right, something like that. Right. You can also have main orthogonal views here, right? It's kind of like the front view here, right there, right? So everything that goes up and down in this face will live in this face. And again, that is the beauty of it, right? Everything that moves up and down, I mean sideways, will live along sideways on the side view. Everything that lives sideways, you see this way. Everything that lives sideways in the side view will live sideways. Everything that moves right to left on the side view will move sideways at 30 degrees in my side view. For example, let's say that I want to do the front view. I come over here and I say, okay, what is this distance? And again, you guys have squares. Say that one's about the size of my pencil. I come over there and I'm going to say it's about there, right? You can do the same thing in terms of the thickness. Say it's about there, right? And then I close it. Boom. And remember, all of your lines will be at about 30 degrees. And use your squares to help you out. Let's actually close the box, right? So let's imagine that I have extracted that portion of it. And come over here and close that down, right? The next thing that I want to do is I'm going to go to the other view. So I already took care of the front view. Again, this distance right here is this distance right there. And then this distance right here is this distance right there. Boom, boom. Okay, next, I can also go to the side view. See the side view there? And come here and find out somehow where that guy point is here. Distance from here to there is the distance from here to there, right? It's kind of like estimate. I'm going to go upwards, little dots. This is not supposed to be visible. And then I'm going to go sideways at 30 degrees. Boom. That will be this line that you guys see there. All right. Let's go. What else do I got? You can go to the top view, and you guys will notice that in the top view, you have this distance, right? Again, this lives on the top, so whatever goes up and down will go sideways here. So it seems to me that distance from here to there is about that distance here. From here to there will be about this distance here, right? So that means if I were to make this cut, it will look something like this, right? In terms of the depth, I can go to the side view, which is this distance, and I could actually draw it here, but I'm not going to draw it here. I'm going to lower it parallel to it, which is on the face. So this distance right here will be this distance, and the other distance will be the same. And then this one will be about there. And then I can come over here. I can get that 30 degrees angle. Boom, boom, boom. I can also go to the side view where I see this distance here and grab that distance and measure it. It's about there. It's about there, right? At this point in time, I can go upwards, and again, this distance is what you guys will see if I want to project this guy at 30 degrees. It's kind of hard when I don't have squares. You guys will have squares. So this distance is about that distance. Then you come back down, and then you make another 30 degrees right there. And then you get rid of all the lines that are extra, which in this case is my box. Let's see, get rid of the lines that are extra. You don't have hidden lines on the isometric view, so you guys are aware of. Something like that, right? And then you start darkening. So you go get yourself your other pencil, and you go crazy at it, right? So go crazy on the thickness, right? So these guys, all of them are visible. And I'm not going to do everything, but you guys have we have talked about visible lines like 20 million times. So you guys should be able to do visible lines, and so forth. Boom, let's do another example, right? So you guys get the hang of it. Again, step number one, width, height, depth, make a box, and start using this view right here, right? I sculpted on the front view. And again, this distance is this distance, this thickness is that thickness. So whatever you move sideways, you're going to move at a 30-degree angle. In the top view, which is the top one, this one, right? Everything that you move up and down, you will move sideways in your ISO view. Hopefully that makes sense. And then I'll have a different color. Let me see. Have a bluish, and everything that doesn't work is bluish. Anything that is on this view, right? And you want to go this way, it will go right here. It will go this way, right? And the ups and downs here will be the same distance in the ups and downs, right? Hopefully that makes sense, guys. Hopefully. All right, let's do another example. Let's do this example. This one I want to make it a little bit faster. That one doesn't seem to me too hard. Let me grab a different pencil. And again, let's start again. I'm sorry if it will take me a little bit to draw it, because I probably should have printed something before I started class. It's okay. Boom, boom. My top view, it seems to me it is about yay. Let's go over here. Okay, 45 from there. Boom, boom. Somewhere about there. So somewhere about let's say about here. That is my side view. Let's make this a little bit thicker. Boom, boom, boom. And then let's give it a thickness about here. Over there. And again, sorry if I'm making it a little bit more sloppy. It's just that I want to get to it as soon as I can. So we can do more examples. The more examples you guys got, the better, right? So let's see that one's about there. It's not that great. Imagine it's good enough for one purpose. Again, what you start is you start with your width, start with your depth, you start with your height. And then you start making a box. Let's say I'm going to start somewhere about there. I'm going to make make this bigger. You start making a line like that. Then you go about 30 degrees. And I told you how I do it. I usually kind of like imagine myself that it goes in 33 to get about 30 degrees. Somewhere about that. And you guys' schedule will not do it like this. You guys have squares. And you guys can do it with the squares much nicer, better than me. Then I'm going to go look at the depth. And the depth, I'm going to make it blue. Right, blue. So my depth will be, if I were to measure it, since to me it is about, it's about there. Let's double check. So somewhere about there. Somewhere about there. Look at this, right? The money, right? And that one is my width, right? So my width seems to me like I did a pretty good job already. And again, it's hard for me to see because I'm drawing at the angle. But I should be pretty close. So double check. See, that one's there. Look at this. Right on the money again. And then finally, I got the height, right? The whole height here. So they say the height is about there. Right? And then you always good idea to go with your pencil and double check your distance, which is yes, right on the money. After you have the width, the depth, and the height, then you make a box. So box, 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 and box. Then after you got the box, you're looking at this view, which will give you the height. So I want to say about there. So since it's about halfway, so we're about there. And since I got that one, I also have the top view. So I'm able to come over here. Come over here. and then the side view will give me this one. And then since I have that one, I can go all the way across, and then I can even return. Okay. After I do that, then I can go to the other views to find distances. So let's say that this distance here will be this distance here, which will be about there. This distance here will be about that distance there, which will be there. I can go to the side view. So let's get that one going, right? And then I can go to the side view, grab this distance here, which will be about that distance there. This distance here, which will be about this distance there. Come back, and then cross them up. Boom, boom. And this is what you guys will see on the top. Go down, connect those two, connect those two, go here, go there, go down, connect those two, get rid of everything else, all the mess that I did. With that guy. And again, you guys don't do it with pen, you do it with pencil. And you do it super light. Once you got the hang of it, then you start darkening things. Okay? Let's do another one. See if I got one little bit more complex. This one should be a breeze. Maybe I'm just gonna draw it without even doing the thing. Again, so if I were to do it, again, I will start with a line. Then I most likely will go 30 degrees. 30 degrees. I will make my box, which seems to be yay. Box there. Come one there. Go back. Cross this one. That one. Go here. Go there. It seems to me in the front I have these distances that I can get. I can connect those two. I can go on the back. This distance equals to that distance. Connect that one with that one. And then connect this guy with this guy. There, 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 and boom. Done. Hopefully that makes sense. Let's go to another example. A little bit more complex. That one was too easy. That one is also easy. Let's do that one really quick. Make sure you guys get as much exposure as you can. How do I do that one? Well, I make a line. Then 30, 30. Let's say that my depth is about there. My width is about here. And from there, up. Go sideways about there. Go this way. Go here. Then go from here to there. It seems to me that one is about here. Then the other one goes about there. Boom, boom, boom. Get rid of the middle. Get rid of the triangle. Boom, boom, boom. Front, top, side view, isometric view. A little bit harder one. Let's say this one's a little bit harder. Okay, how would I do this one? Let's see. If I were to do that one, how would I do it? That one's a little bit tricky. Okay. But first, we need to review how to make circles. Some of you guys don't know how to make circles. Should probably think of how to make circles first. The way you make a circle is you usually, let's say that this is my bullseye, right? My bullseye is where the whole center is going to be. Step number one, you cannot make a box. So let's say box about there. It's about there, let's see, right? First make a box. Then you make a diagonal, and then you make another diagonal. What about that? And then this piece right here, you split it into three parts. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Then the top was here, the other one was there. Boom, boom, boom. And then you connect this one with the 2/3 away, and you create an arc. So create an arc right there. And then you do the same concept on the other side. Create an arc. And then you go the same thing on the other side. Create an arc. And then you do the same thing on the other one, which is, again, try to make it archy. Right? Somewhere about here. Right? Again, it's hard for me to draw because I'm drawing at an angle. But it's good enough for going purpose. Okay. Okay. What about if you were to have a circle, but that circle is at that angle? When you have something that is at an angle, well, let's do an ISO. Right? Let's say that my ISO looks like this, and then I got about a 30 degrees. And what about yay? Let's say I got a depth that is width and the height that looks about there. Let's make it about a square. So square is about yay. Let's go one down, one there. Let's get this guy here. Put that one on the back. That one about there. Right? And you will do the same concept as you would were to do this one. You say, what happens if I were to do it for reals? No. The way you would do it, you say, okay, so can I split this in two? The same way I would do a circle. Well, remember, let's imagine that this is my top view, right? So if I were to imagine my top view, this distance to this quadrant will be about, this distance here will be about that distance there, right there. And the distance from the top, this distance here will be about that distance there, right? And again, at this point of time, I can just make a nice construction line, connect those two. And I can go also to the depth of my circle. Again, this one meaning to be the top, the halfway, it will be about there, and the other one will be about there. And then you connect those two. That's where my bullseye is. This is where this guy is, here. Okay, then you do the same concept, but now you're gonna do it at a diagonal. So you're gonna make a line diagonal here, another one there, another one there, another one there. And then you grab that line, and then you split it into three. 1, 2, 3, 1, 2, 3. Try to make them equal to each other. 1, 2, 3. And then this line you will do about 3 of them. And then this line you will do about 3. Pretty close, right? Try to estimate the location. And then you will make an arc. This is the same with this arc here. We will do it here as well. So we'll make an arc right there. Then you will make another arc. See, the other arc will be about there. Pretty good. And then you will make another arc about there. Pretty good. And then you will do another arc about here. This guy didn't come up very well. See? And a little bit more oval, more ellipsoid. And then you do something similar on the bottom. You can also do something similar on the bottom. Come down to the bottom face, right? Do a diagonal. Split this into 3, diagonal into 3, and then again that will be about archy as you can make it. You make an arc. You make an arc. You make another arc right here. Another arc right there. And again, my arcs are not that great sideways. And then you come over here, you connect those ones too. And then you come over here, connect that one, and then you go down. And again, sorry that they don't look perfect. It's because it's kind of hard to draw sideways. But you guys get the point. That's how you do if you want to have something that is sideways. So let me see. Come over there. Where am I? Here. Right. So if you want to have something like this, how would you do it? Let's see if I can thunder through it. Well, step number 1, you will come up with a line. Boom. Then you will come up with 30 degrees. You will get the depth. In this case, I have a circle, right? So the circle will be the diameter on the bottom, which it seems to me is going to be, since a circle will be about the same on both sides. Then you will come upwards. Let's say about yay. Let's come over here, go upwards. So about there, so about there, so about there. Pretty good, pretty good. This point of time, I can go to the top, and it seems to me on the top I have 2 circles, right? This is taper on the top. So I'm gonna do both of them. And you guys will do kind of like get it somewhere there. Then you guys could grab this line, split it into 3. But if you get good enough, you should be able to just make the arc right on the money. There is another arc, which it seems to me it is before, somewhere here, right? The end. And then you will do the same concept, create a platform, grab that line, divide it into 4, divide this one into 3, grab something like that, right? And then grab the arc, something like this. And something like that, right? One at a time. And then you will do the bottom one, right? The bottom one, do the same concept on the bottom, connect them sideways, and then go and create another arc. Boom, 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 right? Then it seems to me that I have one that it has a bigger diameter, and I think I did it more to scale. This actually a little smaller. This is that one is about the square that looks like this, right? You will make an arc, same concept, make a diagonal, use the same way you did the other ones, diagonal, split into 3, and then you got there, you connect sideways, here to there, from there to there, and then you get rid of everything else. Because remember, you do not have any hidden lines, and you also don't have a square that defines everything else. Boom, boom, boom. All right, so let me see. Let's take a look at the other examples. Boom, boom, boom. We talk about the general. These are the obliques. Again, we have different type of obliques. Okay, so let's see if I can explain you what the oblique is. And again, this guy will not really. This guy, what it says, if you want to do an oblique, and this one is your general, is that when you go and you make your front view, so I'm making it right now, and let's say my front view looks like this. And I want to do a general one, right? So let's say general means I'm going to grab this, which one is my my width, and I can get the depth. And this one angle, usually it is about 45 degrees. So what is 45 degrees? So if that thing is 90, 45 will be somewhere in the middle, right? It's the same way that if I want to do a 30 degrees, I can split that one into 3 parts. And that will be about 30, that will be about 60, that will be about 90. My case for the oblique, they're usually about 45 degrees. So I go 45 degrees will be about there. And whatever I see here for my general will be between a half to a full size, to the whole thing. So I say anywhere between here to there, that means I can have a depth of a half to an inch. So I say I want to do about 3/4. So from here to there is about yeah. About yeah. And then you just grab all the lines that you see in the front, push them on the back. And when you got in the depth, repeat the front view in the top. Boom, 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 boom. Repeat it in the back. And you will have a general oblique drawing. Boom. So whatever I have, let's call this guy D. This guy here will be, I don't know, let's call it 3/4 D. Between a half to a 1. Okay? Let's do another one. So this one. This guy is a cabinet. Okay, well, cabinet means, I don't know if you guys noticed this one, but this one is not a, from, this guy is an isometric view. So they give you the isometric view. Okay? All right. So if you guys recall, when you have your isometric view, that means this distance here is the width, this distance here is the depth, and the distance here to there is your height. I want to hope that you guys can see that, right? So if you guys want to do oblique cabinet, if you guys recall, when we started the oblique views, we're starting with the front view. So the way to do a cabinet view is to come up with a front view as if I were to make a regular front view. So let's say, how do I know I want to make my regular front view? Well, because I know the width and I know the depth. Let's say that I go and I measure the number of squares on the red line. So you guys want to do by squares. And then I come over here by the height, which let's say about the height's about there, right? Okay, and again, it's not to scale because there we go. It's a little bit more to scale. So about there. So that's the width and that's the height. Okay. Now in terms of the depth, because this one is a cabinet, I'm going to be looking at the depth in my other view, and I'm going to choose about half the way. So if the depth at 45 degrees will be about, say about there, I'm going to go half the way. This cabinet. Okay. Somewhere about there, that would be my depth, and then I'm going to go upwards. Somewhere about yay. And again, the other one also will be at 45 degrees, and that will be my square. Hopefully it makes sense. Then I can go to my isometric view, and I can dimension this distance, distance right there, and which seems to me is about half the way, so I'm going to go somewhere about there, and then I'm going to connect those two. That will be my front view, right? And then somewhere half the way, I have this top stuff, which seems to me is also in the middle, so it will be about there, right there. And if I were to go down, and if I were to go to 45 degrees, I will get that. And then if I were to come down by distance, not depth, a quarter of the depth, which in this case will be about half the way of the depth, which in my case, because I did it to a half of the depth, will be like a quarter of the depth, because this is the depth. This is what I do when I do cabinet, and that guy is about here. So you do it by proportion, so you guys can see, right? The cabinet one. And then right after you do this, then you connect this one with that one. Somewhere about there, right? Then this one will continue upwards, this guy will go sideways, this guy will go downwards by the distance, it's the same distance, and then you will come about here, right? Remember, whatever I see in the front view, every view that is parallel will be a true size, okay? And because this guy is an isometric view, by the way, when you go and you create your isometric views, whatever I'm drawing to green, in terms of the widths, would be a true size in your front view. For example, if I were to draw this in my front view, let's see, it looks like this, and then my front view looks like about yay, right? So that's my front view. This distance should be equal to that distance. This distance should be equal to that distance. This distance should be equal to this distance. That distance should be equal to that distance. This distance should be equal to that distance. That one will just continue as if I were to do the front view, right? That's why it's called grab the front view, and anything that is parallel, just copy it over and over and over. Then I'm going to go backwards, and then I'm going to finish up, and then I get rid of everything else. This one, it is a cabinet oblique view. Whatever you get to see in your front view or parallel to the front view would be a true size when you go and you do your cabinet view. Okay, let's do the last one, and that way you guys can start working with this. Okay, this one, man, this one's tough cookie. Let's do tough cookie. Another shit. Okay, step number one. First, we gotta decide which one is going to be our view that we're gonna be using. It seems to me this one is an isometric view as well. And you guys remember, I told you, the way you do it, you look and you choose the way you make your oblique. You choose the hardest one. So in my case, my hardest view, I want to assume, is probably the one that has the foam. Okay, and then you can also make a square, by the way. So I can make a square. Square. So what about there? What about there? Right. So what about there? Let's put it on top. So what about there? So what about there? And again, sorry, I am measuring with my I'm drawing with my mouse. Okay, now that we have that one, I know that we can create our front view, but in my case, my front view is the one that has the foam. So I'm going to come over here, and I'm going to make a box that's going to represent my front view, which I'm going to say is about there, right? And again, that is the beauty of having isometric views, because isometric views in itself don't need true sizes, as long as I move sideways at 30 degrees, or up and down, right? So I can go to the one sideways distance, which tells me my depth, and that will give me this one, and then I go the height. And in terms of the depth, this one is a Cavalier, which is the full depth. So whatever I measure in terms of, in this case, in terms of width, will be my size that I will measure here. And again, it's usually about a 45 degrees, so that makes 45-ish. So 45 is the one there. That's about my depth. I can come up, I can go sideways, somewhat like that, and go the same thing, 45 degrees, right? And again, whatever you guys see, whatever you guys see here is whatever you guys see there, and whatever you see here is whatever you see there. And the height of it is meant to do this one. I don't think I did a pretty good job in terms of height, but I guess you guys get this. And again, sorry, I'm drawing at an angle, so it's kind of hard to do it correctly. Next thing, I go and I know that whatever I see on the front view or anything that's parallel to it, and again, in this case, I want to project anything parallel to this view, will be a true size. So if I go there, system, this one is the front of it, and then the back one will be if I were to do, let's see if I can give it a depth here. Anything that is parallel to it will be a true size. For example, I can go and I can give it a shake there, right? And then I can offset by the distance. Let's say there is an offset about there. How do I know this? This is because I have the oblique drawing. I mean the isometric view drawing that tells me the true size. So I can do the same concept if I were to create a plane that is projected. It will look like this, right? I can also go and make a circle. I show you how to do the circle, right? You guys look for the bullseye. Once you got the bullseye, you can divide it into diagonals, divide the line into 3, and so forth. Look over here. It seems to me, in terms of this distance, that's what you will measure in your isometric view. They come over here, and go sideways, boom, 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 right? This guy will be true size. Like anything that is parallel is a true size. And then come back, boom, 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 boom. Okay, not too bad. Okay, so anything that you were to do in an isometric view that it goes at 30 degrees sideways will be, if you were to go and you were to do your top, your front, your side view, is if you were to do your cube that were to look like this. This distance should be equal to that distance. This distance should be equal to this distance. That distance will be equal to that distance. You create your box. And any dimension that goes this way will have to be a true size that way. Anything that moves this way will be a true size that way. And anything that moves this way will be a true size that way. So you guys see that, right? When I go and I look at your drawings, I'm expecting to be, this is an isometric view. This is actually an engineering drawing. So when I go with my pencil and I go, boop, that should be able to see the same distance. Now, when you're doing an oblique, what you do is you create your front view, or the one that has the most complex shape. So in this case, let's assume it's the front view. It has to be a true size. And anything that is parallel to the front view, which is a complex shape, will have to be a true size. You guys are doing cavalier views, which means the depth should be equal to that depth. So this distance should be equal to that distance, but in this case, my angle should be about 45 degrees. While these guys should be about 30 degrees. How do I do a 45 degrees in squares? When you got square, and if you go from corner to corner on one square, it will take you 45 degrees. You don't know how to do 45. When you have that distance, then you can do the other 45s, and boom. Hopefully that makes sense. Whatever you see here and any parallel behind it will be a true size. So the same shape that you see here should be the same shape that you see there. And everything that is parallel. Oblique, cavalier. Which I believe that's what you guys are doing. Whew. See, I finished, guys. Finished. I wanted to start AutoCAD, but I think we're going to start next week. All right. Let's do this. By the way, for the people that are participating in the event that is happening tomorrow, I send you guys a message on Teams. Make sure you read it. And this is the time that you guys give me your roster number, by the way.